webinar will be, oh, yeah, thank you. This webinar will be quite technical. And I will, within like 1 hour, I will tell you about AI agents, what are AI agents, and then we'll show you how to build small agentic Python script. So my name is Nikolai. I'm a founder and CEO of Hyperscale and Advancium. At Tech Products, we teach people computer science and use AI to enhance learning. And also I'm a member of Sunday Club, which is a hacker group from MIT and Harvard. And as an introduction, we wanted to ask you a couple of questions. Can we launch a question? Yeah, thank you. So Zoom should show you first question about like your background, so I understand more like what you know, what you don't know, and maybe what like adjust the level of today's talk to you. Please fill in this question. I think that's the first one, and I can see only one poll at a time. So we will need to launch the second question later. So please fill it in while you're filling it. The question says like, what's the most complex AI technical project you implemented to understand your background? While you're writing it down, I will start. And yeah, what are AI agents? It's kind of lauded and hyped term right now. So like last 2 years, I think AI was quite hyped, and this year and also like some part of last year, there were a lot of hype about AI agents, and there is no clear definition of like what AI agent is and what it is not or something. But there are two main like views or qualities about what constitutes an AI agent. So the first one is it's basically AI systems that are more complex and go beyond a single prompt. So when you prompt something like prompt LLM something and get results, it's a simple AI interaction, like LLM interaction with the AI model. And agentic systems are just a more complex software systems which are like have multiple prompts or have like some other things which we will talk about later. So the first definition is that AI agent is just a complex AI system, and the second definition, which is more like less technical, more on a business side, it's AI systems capable of operating independently of humans or controlling your device. So, for example, an OpenAI operator, like OpenAI calls it engine and agent, sorry, because it operates independently based on your request. And these two parts are actually interconnected because previously most of AI applications and most of AI like systems were not able to handle like complicated, complex tasks, and therefore it was dangerous to deploy them to operate independently, and not dangerous and sometimes like meaningless. So you can like, or no, you could like 2 years ago create a support agent who answered like support tickets, but the quality was poor. But during the past years, mostly past 1 year actually, people learned how to build more sophisticated AI systems. And this more sophisticated, more complex AI systems, along with also progress in foundational models, unlocked like a higher level of quality, basically, and accuracy of AI systems. So nowadays, more and more people, companies, organizations are building AI agents and deploying them So agents are operating independently and completing like more like harder and harder tasks more and more autonomously. So overall, AI agent is complex AI system, sometimes with autonomy, with agency in a like regular meaning of this word. And basic building block of AI agent is so-called augmented LLM. So LLM, large language model, with some additions, and these additions can be like retrieval, which is RAG, and LLM can query a RAG and get results. For example, some tools, and we will see a few tools later on. So LLM can use this tool as a human use tools to do it stuff. And tools also are called function calling in some LLMs or some products. And also important part is memory. So usually large language models, they don't have any memory. You just prompt something, it outputs something. It does not store like memory of your query of your other knowledge. And most of agentic systems do have memory in some way or another. Sometimes like memory and like retrieval part are similar because you can store something in database and you can use RAG to retrieve it. But also memory can be just a simple like RAM memory, like some state of your code, which is used by LLM prompts. And agents, basically it's something that like this is kind of building block which interacts with environment. So for example, human asks something from LLM, like I don't know, buy me groceries, or write this function or this app or something like that. And LLM takes actions on an environment. So the autonomy basically is here. So LLM is not not locked like in itself, but it interacts with an environment. So it takes some actions, get a feedback. For example, if it's code writing tool, it writes some code, can run some code and test it, and so on and so on until agent succeed, and then it stops. There are a lot of hearts. And this is a simple high-level, basically high-level description of a coding agent from Anthropic. So Anthropic has a nice article about building effective agents, and these illustrations are from their article. And this is a high-level flow of how like regular coding agent works. So human sends a query to interface of this coding agent. For example, it's like agentic ID or something. And until the task is clear, human and LLMs, basically an agent, discuss and clarify, like refine what needs to be done. And when LLM understand everything that needs to be done, it also gets like additional context from interface. For example, like other like files in the code base or like whatever like we have. And then LLM by interacting with environment, it completes a task which was clarified here. So it like search files, like search like code base for like files where they need to make a change, like write unit tests, like write code, run code. If the code is like basically wrong or give errors, it can like try to understand like whether this error is fixable or not, and try to fix it, and then run again, and so on. So until it's runnable or test passes or like in any other completion like completion state is achieved. It completes the tasks and display it to human. So basically, it's a complex LLM-based system which can complete some tasks a little bit autonomously. So sometimes, yes, as you may know, like AI code generation sometimes do not work like on complex tasks, or sometimes give some strange errors, like strange code, which leads to errors and so on. So it's more like intern developer or sometimes worse. But overall, so it's example of complex AI system which can do some things. And if we like like other like way to think about it, or like actually the same way but more complex way to think about it. So agent usually have memory. I already told about it, like short-term memory, your variables, basically like state in a RAM when agent is executing, and long-term memory, like databases, they can store something in databases. Agent has and can use tools, and there are like multiple tools, and in popular frameworks like LangChain, there are plenty of like tools like calculator, calendar. So for example, for calculator, as you may know, LLMs are not good at math. And also, so they cannot sometimes like they cannot just calculate stuff. But LLMs can have calculator tool to use to calculate something. The same as humans, actually. Like humans maybe cannot like multiply large numbers in our brain very fast, but we have calculators. So if we need to multiply like large numbers for some task, like we are doing some task and we use tool like calculator to multiply these numbers, the same for AI agent. And in this case, AI is kind of similar to human. So it can do something, it cannot do something. And for what it cannot do, it can use tools. Yeah, other tools like include calendar, code interpreter. So for example, for complex computations, you can notice like ChatGPT sometimes. So ChatGPT is agentic product on top of OpenAI models. So for example, ChatGPT, sometimes if you ask it complex question, underline, like it writes some code and run it. So instead of trying to figure out the answer in like AI brain itself, it uses AI brain, let's say AI model, to write the code to compute a result for you, and it runs this code. And also like search and other tools, like search, like ChatGPT can go online and search for something. It's a search tool basically. And one important part to make AI agents and AI systems like produce better results is planning, similar to chain of thought and like reasoning, which happens nowadays in some reasoning models. But basically, agent can, when you give a task to an agent, first it can plan like how it should complete the task, and then execute this plan. And also, in more complex systems, you can use like smarter like reasoning models to build plans, and cheaper, faster models with lower intelligence and non-reasoning to execute some tasks. So you can differentiate like planning apart from executing this plan using different models, for example. And also if you have, I don't know, multi-model agent, like it can plan with a text-based LLM, like reasoning, and maybe like you need to generate like images or videos with other LLMs. So yeah, planning can be separated from executing this plan. And yeah, agent basically using these tools and like directly by itself do make some actions on environment, as we discussed here, get feedback from environment and continue until their task is done. And the popular frameworks are LangGraph from LangChain, it's more lower level like framework, like it's harder, like need like more details like to build, but it's more controllable. So you have more control over agentic system you're building. And more abstract, less controllable, but more magical frameworks are CrewAI and AutoGen. Also, AutoGen, like initial like founders recently like separated from Microsoft. So AutoGen is some interesting state where like there is AutoGen and AG2, which is fork of AutoGen done by like founders of AutoGen, but out of Microsoft. And if we will have enough time, we will go through LangGraph and CrewAI today, or maybe just one of them, if you don't have much time. There are multiple tools like search, code execution, web browsing. I already told you about like search and code execution. Also, web browsing is an interesting use case. So there are more and more tools for agents that are basically a browser. So your agent can open a web page as a human and like try to find something there. And so it can like go to like with search, you can go like to Google, find some results based on what you need to do, and then like using web browser, you can like navigate on these websites. For example, if you have an agent who buys you like groceries every week, it can go to Amazon like in its agentic web browser and like make the order and from your account. So it depends on what you will code there. And yeah, there are like more and more tools. There are like companies and startups who are building specific tools for agentic world. So like more and more possibilities will open for AI agents to interact with with the outside world. I think even there is like even one startup of providing like a human tool to AI. So basically, if AI is not able to complete some task, it can call, like using this tool, a human, and human will help AI to complete some part of this task. Similar to, I think, Amazon Mechanical Turk project. So basically, like AI can interact with humans, also using tools, and with outside world. And as for memory, there are like three types of like memories in memory state, which is like in your program, like variables, like state. The second one is conventional databases, like Postgre. Like you can just use them as a regular database, and more and more popular are becoming like vector databases because using embeddings, like AI embeddings, you can store and search by meaning in vector database. So in like conventional like relation databases or NoSQL database, here still like you can search, but in vector database, if you use embeddings, you can like find similarities, like search like some concepts similar to your concept, so it's closer to human memory. Because yeah, we do not store like some particular values, but we store something like fuzzy in our brains, let's say. Okay, let's go next. Let's see, do we have questions? I have seen some of the discussion on baking some weights directly to LM to make the LMs perform the calculation accurately. How does it different than this? I'm not sure what was this asked about. What is this in this question? But if it's about calculator, so making calculations using like default calculator, like default computer system, is much easier than embedding it, like some changing weights in LLMs. The same as with humans. So yes, like humans can learn how to like multiply, add numbers, like do some math. But like if you work on something and you need to complete a task and you have like a large number to multiply or to add, it's much easier to use conventional calculator than to use your brain to think about it like longer, and maybe like you will make mistakes. So some tasks like calculation and like complex like logical problems, LLMs are not able to do, similar as like humans are not able to do without additional tools. And that's why like calculator or like additional like code execution is used because it's just easier, simpler, and correct. Second question, grateful for doing this. Thank you. Can you show a demo of how it works before deep dive? I will show you. Yeah, after this presentation, I think in about 10 minutes, I will code you a Crew AI agent and show you how it works. What about graph database? Does it make sense to use it with agent? I think yes. It depends on your like domain and application. But yeah, most of agents, most of AI like systems are working with vector databases. But you can if your particular problem, if AI can benefit from using graph database, you can use graph database. You can do whatever. So AI agent is not something like special. It's just code which runs LLM and have like more logic outside of prompting. So you can use whatever you like, you want, and also try different approaches because it's kind of fast-moving field. Like nobody understands it clearly. There are a lot of like new tools, new frameworks every day. So yeah, you can try using graph databases. I have not heard like about like specific use cases for about it, but yeah, maybe it's just not my like domain. One more question. I'm Java developer. I need to generate web application. What is the best AI tool to do based on human prompt? Where can we learn that? So you can use. I will use Windsurf later on. So it's ID. Also, like most of developers use either Windsurf or Cursor to build, especially like web apps using prompts. And for less technical people, or if you are like not so familiar with Python and JavaScript, you can use Replit, for example. Replit agents is kind of a nice tool to build small full stack web apps. Okay, let's go to the next session. I will show you a little bit some patterns of agentic patterns, basically. You can think about them similarly to OOP patterns, like objective-oriented patterns like singleton or like facade or something like that. We used to develop like a software using software design patterns. And the same is true for agentic systems. There are some common patterns which developers can use to build agentic systems and discuss agentic systems with each other. So like most common pattern is basically prompt chaining, and like LangChain framework is completely like about chaining. And for example, you have like one LLM call, it outputs something. You may have a gate like to understand whether it should exit the flow or go further, and then like next LLM call, next LLM call. So you can like, basically, instead of building a single complicated prompt, you can build many smaller prompts. Usually AI is like executing like and answering like simpler, more focused prompt better. So you can improve quality of your system by splitting prompts into multiple one and chaining them. routing is also quite popular. So, for example, if human asks some question, like asks your system, like your app, AI app, some question, you can, for example, route this question to different prompts, different like LLM calls, which will answer this question better. For example, if it's like a teaching assistant, and you have specific prompt to answer like math questions, biology questions, and history questions, but like LLM router can understand what kind of question is this and call specific LLM like prompt to answer this question better. So basically, you can split your like logic into different parts, debug and test each part separately, make like the first prompt works better for math, second prompt works better for biology, adding like more tools, more like database, like math database calculator tool to this one, I don't know, biology RAG database to this one, and so on. So routing is quite popular in agentic systems. Also, parallelization is popular to just make everything faster. If you can build like multiple, if to complete a task, you can like parallelize some prompts. You can call them not sequentially, but in parallel, and then aggregate the result. For example, if you have a let's see, you have like a planning stage, you developed a plan to execute your task. For example, you need to write I know, essay or poem or whatever, and you first understand, like it breaks this as like build a let's say like a structure of this essay, and then you can write like first part, second part, and third part independently in parallel, and then aggregate them, for example. Or if you need to write a complex like system, like coding agent, it can code like some files independently and then try to aggregate them so they work together. So this is parallelization. And orchestration, like it's kind of similar to, so it's a combination of routing and aggregation, but synthesizer. So yeah, you can call multiple LLMs. You can call one LLM. You can synthesize results. So it's basically like more complex version of routing and parallelization and aggregation of results at the end. And I think the last one is very popular. So it's very basic and popular. Evaluator optimizer. Sometimes people call them like editor or reviewer. You have one prompt which generates solution, and another prompt which evaluates like quality of solution. So, for example, if you have a like support like AI agent, this one, the left one, can generate reply to customer ticket. And this one can evaluate whether this reply solves the customer ticket, whether like it's written well, and so on. And it either like provide a feedback for next iteration, and then they work together like multiple times until this reply to the ticket has a good quality. Or yeah, it can like reject and say like rewrite it. Rewrite it from the beginning. It's also sometimes good to use different models. So, for example, you can use I don't know, Claude Sonnet as to generate like initial reply, and use DeepSeek or GPT to evaluate it. So you can use like multiple models in this pattern, and they will help each other and like debias each other. And also you can use some like cheaper model to generate result and like more expensive model to evaluate result, for example, or like any different combination, however you want. But it's a common pattern with like cycle of generating something, review and editing, and then generating a review and editing, like incorporating this review and so And yeah, if the quality is good enough, it outputs the result. Okay. Before the demo, do we have more questions? We don't. Okay, let's go to the demo. We have about half an hour, and I will try to live code with you, for you here, and we will see how it goes. So let's start with LangChain. I have let I probably should make it larger so you see. So this is WinSurf IDE, which is agentic. So I will not write the code, but I will generate the code about agents, and we'll try to run it and explain to you. Let's maybe start with, instead of LangGraph, let's start with CrewAI, because like the code will be smaller and easier to understand. So we will build Python AI agent that use tools to answer like complex queries. And let's yeah, let's keep the description as it is and use CrewAI framework. So CrewAI is a popular framework to specify agents and agentic systems. What's going on? Okay, it's continuing, and it's more declarative. So it's specifying some agents who can work with each other. It's harder to debug. So if you have like very complex system, or if even in a smaller system something doesn't work, it's sometimes harder to debug and make it work. But for simple agents, it's relatively easy, straightforward, and easy to understand. Okay, this is WinSurf. Okay. The question is which AI tool it use, like ChatGPT or DeepSeek in background. I think this one right now uses called Sonnet, but you can switch to any other model. Okay, so it created me tools, but it did not create agentic code. So it's actually just specified tools and not build anything. So you can see here it builds like using CrewAI. They have agent. They have agent and crew. Crew is basically multiple agents working together. That's why it's called CrewAI. And there is actually one agent which have a goal and a backstory, and this information will be used by the prompt. So CrewAI will generate prompt for this agent to use. And yeah, so this research agent, your advanced AI assistant, and so on. It actually equipped this agent with search tool and calculator tool. Search using DuckDuckGo, because it's, I think, free and don't require API key, so it's easier. Google SERP tool is usually better, but yeah, for demo purposes, DuckDuckGo is easier. And calculator. And yeah, and a task. Okay, we'll see how it goes. Yeah, so it generated something. Let's try to run. Also generated CLI, which is similar to agent. So that's how agentic AI coding works. Sometimes it generates some strange result. But let's try to um, um, let's try to run it. Um, um, I answered the question. The first one, can we do the same thing with IntelliJ as that is allowed in my company? Yes, you can do. So IntelliJ has a AI assistant, and also for agentic coding, it has Juni. No, not this Juni. Coding agent. You need to join like a waitlist, and it's early access. But yeah, JetBrains has something similar for agentic coding, and also so I'm generating this code because it's just easier and more like I can show you both like AI generation, like code generation and agentic implementation. But you can write this code like in PyCharm, for example, anywhere you want. Okay, so let's try to run agent. Agent. Okay, we need to ask some query. And yeah, we don't have API key because we haven't specified it. So we're trying to call like OpenAI and don't have any key. Let's use open router for AI calls, and I will go get an open router key for us to use. So I think it right to call light LLM. Yeah, but we will use not sure why it's writing both agent and CLI, which looks similar, but yeah, let's work with agent. instead of it looks like our experiment with code gem is slowly failing. But if it doesn't work, I will show you one of existing projects. Yeah, it's an illustration of like how a agentic system works. You can see Cascade in Windsurf. Basically, it's agentic software, and yeah, it also like has LLM like ID tools and so on. Vishnu is asking why we use Juni. It's not Juni, yeah, it's just Juni from JetBrains, so it's from IntelliJ. It's a code gem, but yeah, you can just write code in any IDE or like without ID in Notepad. So agentic systems are just software who use LLM to achieve their results. Okay. Um, how reliable is AI agents? Well, they're as reliable as you implement them. If you're building your agentic system, it depends on you. If you like build it like very simply with just a few prompts and asking it like very complicated questions or do some complicated stuff, it will not be reliable. If you implemented like lots of custom logic and like added some like information and so on, it will be quite reliable. So there are some agentic startups who work in like legal healthcare areas where usually like the correctness of results are important, but it's not simply like ChatGPT wrapper. It's quite complicated systems with lots of like additional information, lots of checks, and so on. Yeah, I don't know what. Okay, let me show you. Since we don't have much time, let me show you maybe some of the previous projects. For example, I think I've built this one. Built this one about a week ago, and this is QAI. QAI agent who build the movie, tried to build a movie, and it's only text-based as for now, but it basically gives you outputs for a movie to create, including prompts for image generation and video generation. This agentic, it's also built in QAI, and it has multiple agents, which are here, but not in the order. But yeah, here. So the story writer who writes a story, filing short movie script, and then so it's a story writer with some backstory, Then title generator, who generates a title of the movie based on a story. So these agents in a crew work together to generate small movie. Character designer who generates like, characters for this movie, because this agentic system was supposed to generate prompts for image and video gen, and I needed characters like, specific, so video will be consistent, because video gen is still like early stage, like video models are not as good, and by generating specific characters, images of characters, you can generate more consistent video later on. Like scene designer who takes these stories, these characters, and split it into scenes by like 5 seconds each, because also video generation, most video generation models are limited to 5-6 seconds nowadays. Music designer who generate prompt for music generation for this film, and narrator generate a script and create subtitles, which we can like embed later on with the video. And so these agents work on a task which I also specified for them, like write a short movie script, requirements, output format, and so on. And yeah, like, so this should be 5 scenes, each scene like 5 seconds max, output format, and expected output is well-structured movie script, and so on and so on. Then the second task is for character agent. So each agent basically gets its tasks. And in essence, it's like quite complicated, like large task, but which we split into different tasks, and also specify agents to complete these tasks. Each agent can complete multiple tasks, but again, this is a simple pipeline where each agent complete a single task. And I can also show you, I think, tools. So we have also result savior agent, which is a little bit separate, which goes like through the history of conversation of these agents, and save results to files so we can use them later. Let's try to I can show you terminal actually. Like no I can show first. Okay, let's my opening API, I need a new one. Let me get a new key for you. Okay, okay, I added a new key. No, Mhm. Mhm. Yeah, I fixed OpenAI key. Sorry for that. And I started this crew, and basically agent story writer. So this is debug output. Agent story writer got this task and called OpenAI API to give me this result, like title, second chances, characters, scene, and so on. Character designer I got a task to describe each character in details. So we have like Sarah and David. And this is image generation prompt. So this crew was supposed to also interact with image gen and video gen models. It's not implemented here, but basically text model generated a prompt for image model. So later on, like we can generate images for each character. And like theme designer splitted this story into 5 things with each character. So Sarah doing something here, and also it's also image gen prompts. David doing something here, and so on and so on. And music designer also wrote prompt for music generation for each theme, like narrator, created subtitles for this movie based on a story and themes. Yeah, title. They created a title brush stocks of redemption, and the result saver agent outputted everything here. So this is a small agentic script using Crew AI, and it's important to understand that basically it's like Crew AI and LangGraph are frameworks to build agentic networks a little bit like easier than with just pure Python or Java or whatever other language. So they have some abstractions which helps you to build it faster. And but it's not magical. It's just a system, like software with some prompting, and also they like can use memory and tools. I'm not sure like we have tools here, but yeah, maybe like saving tool. So I cannot show you tools right now, but yeah, so it's a simple Crew AI agent who do some tasks. Moreover, like this script has no input, so it just generates like different stories every time. But yeah, I could, for example, ask for some like theme or for some like specifics to incorporate, and story writing, like script writing agent could maybe use my input to build it. And also we don't have much time, but I will let me show you um, show you have a LangGraph example. Which I can show you briefly. This is small LangGraph example, and LangGraph is also a different framework to implement agents, but it's more lower level. So you are designing a graph of interactions between agents, tools, and I will just run through it. Okay. And this particular graph, so it's visualized here. it will have a planner, an executor with a couple of tools. Oh, I can probably see it. And when this planner and executor came up with some result, they output final answer and will run all. So we have a planner agent who are planning, like, so human inputs a task and planner create a plan how to execute it. And this agent actually has available like search tool and calculator tool already, and it should be working. And we have a tool executor, which is also agent. So we have planner and tool executor as like separate agents. And tool executor does have these tools on hands to use, and calculator is just calculating like what's given, and DuckDuckGo is from LangChain library. And final answer agent takes this previous conversation and gives you a result. And LangGraph have a graph abstraction where you build like connections between this agent. So it's like you need in CrewAI, you don't need to specify how these agents interact with each other. But if you want to control it, like it's hard to control. But with LangGraph, you need to specify, and it's easier to control. It's easier to build like larger, reliable systems. And this is a graph. And for example, what is population of Tokyo multiplied by 2? This is a query to this agent, and we can see that it like human message, and then this is AI like first prompt, like planning prompt, and AI decided to use search tool, DuckDuckGo. Then this is also our prompt. AI like trying to using like search results, trying to understand what is the current population of Tokyo. It found like using DuckDuckGo that this population is 37 millions. Now AI, so this is planning prompt. It's the same as before, so it's a prompt from the code. And it decided to use calculator tool and specify like what should be calculated. Then using calculator tool, it just eval in a Python. It gets result, and then planning step again. Planning agent understand that like it can finish because it basically should have result, and then final answer agent who formulate the final answer formulated this output. So everything human message is like prompts, or the first one is my query, and AI message is what AI replied. For example, we can ask, I don't know, what is population of Boston divided, I don't know, divided by 10, and it will do something similar. So basically it can, using planning and these two tools, it can try to solve like any kind of problem question which requires some search and some calculation. So it found some population, divided it by 10, and so on. And came up with the answer like 6,500. So we don't have much time left, and this was example of LangGraph. And I will show you a few more slides, and we'll answer all your questions. So if you have questions, write them down here in Zoom. So as for further reading, we will share slides with you, but there are some like videos and guides, especially a guide from Anthropic on building effective AI agents. It's good. And there are some like short AI agentic courses for like specifically like for LangGraph and CrewAI on deep learning. And we will hold more advanced AI agents workshop, which will be like about 2 hours. For participants of this webinar, it will be paid, so it's not free. But yeah, it's exclusive for participants of this webinar, so I will not repeat like some basics of AI agents. We will just go straight to coding. I will give you some structured assignments where you will need to code AI agents with tools. It will be on March 20th, and you can use this core code or this link, and we will also send out this information afterwards. So within 2 hours, it will be like very hands-on and not like me talking, but yeah, mostly you doing, you're writing code and trying, and me and teaching assistants will give you feedback. And also after this workshop, like you will need to complete the assignments, and we will give you feedback after the workshop on your code. So like we will, especially like if you have some ideas on like AI agents, you can bring them, or you can like, work on our assignments. And this is so this is a short workshop, and also we have a long like AI engineering bootcamp, like a 8 months long program. The next cohort of this program just started, I think, this week or like yesterday. So it's just starting for 8 months long. And if you want to join, and it's more so the workshop is more advanced, and bootcamp is like targeted for beginners, but also like if you know how to code, you know how to code since you're here, it will be useful for you to. This bootcamp will cover how to build AI apps, all details, and AI tools which are relevant nowadays. And you can join this bootcamp with this promo code, which we will also send out to you. But it's kind of high commitment, so you should be able, like, you should decide that you're ready to spend about like 10 hours per week for 8 months to become AI engineer, or get to like understand, like learn how to build AI apps, like very complicated ones, much more complicated that I showed you today. And yeah, that's it. And I will answer your questions. We have a few questions in the chat. Godswill is asking, can I use self-hosted LLM like Olama, for instance, to build agents? Yes, you can. And it's yeah, you can use Olama. You can use any LLM. So you just need to call LLM. You can call it locally. You can call it remotely. Yeah, it's also for some like enterprise environments, it's also like sometimes required and more secure. You can like, deploy LLM within the infrastructure and use it. You don't need to use OpenAI. You don't need to use any specific AI provider. You can use whatever AI provider you want. Also Claude, DeepSeek, something like that. Another question is, can you show simple web app prompt doing CRUD operation? Okay, we don't have time for this. We don't have time for this, sorry. But for example, if you're using Windsurf, yeah, you can build a simple web app. So what I showed you is basically a Python script. So it's a backend. But yeah, you can generate a front end for it. We don't have much time for it, but I can actually promote. Like recently, we released lighter plugin for Cursor, which is Cursor. It's working for Cursor now. I think it doesn't work for Windsurf yet, but you can install it. You can install Cursor, install this plugin, and you can build few projects using AI, like agentic coding in Cursor, and we provide like prompts for these projects. And I think like a few of these projects are full stack apps. So with a front end and a back end, and you will see prompts there. So you can use Enlighter. So it's called Enlighter for Cursor. It's you can install it to your Cursor ID if you have. And you cannot install it for IntelliJ. It's a VS Code based plugin extension. Okay, I think we answered all questions. I think so. Thank you all for joining. Thank you for waiting. Yeah, sorry that we were late. And AI could not generate my demo from the first prompt. It happens. What's the best option? One more question. What's the best option price quality at the moment for CodeGen? Sonnet is really good for CodeGen as a model. And as a product, Cursor, Windsurf are good. They're free tiers also. Like you can play with the free tiers of these products. And yeah, we hope also Journey for JetBrains will be like good when it will be published to all of us. Jigstaff, I don't know this one, so I cannot say anything. Okay. Anyways, I answered all the questions. Thank you all, and have a great rest of the day. Sign up to either workshop or bootcamp if you would like to. We will send out links as a follow-up email. Thank you. Bye-bye.